Yeah, no, no,
Take your
awesome.
time.
Scott is here as well. Awesome. All right, I just kicked on the start the recording. So I think Sandeep and I took a last month off since we started this user group a year ago. That was our first break, and now we are back with an amazing speaker, Nicola. Like everybody knows him, I think, in data community. So thanks, Nicola, for joining. Just going to take 2 minutes here. Quickly introduction. My name is Purvinder Chana. People call me Purv Chana as well. I'm local here in Vancouver. I run my own consulting, pretty much focused on Power BI and Fabric, all the stuff. I have a YouTube channel, Power BI How To. Not as great as Nicola and other people, but I try to contribute as much as I could. And I'm also a Microsoft Data Platform MVP. And my friend and my partner in organizing this user group is Sandeep. He moved to Microsoft. Sandeep, all yours.
Hey guys, nice meeting you all. Thanks for joining, and thank you to Nicola for presenting and accepting our invitation here. Really excited for him to have here. Always nice to meet him, see him, and then learn from him. We all have benefited from him, so I'm really excited for this session and appreciate the time he's given us. Mine is Sandeep. I like as Parvinder mentioned. I just recently joined Microsoft as a part of the Fabric Cat team. I was MVP, similar to Parv and Nicola earlier, but been part of the Fabric and Power BI community for a long time. I love our community, and I love that we all get together and share what we learn together, so which is awesome. So this is another effort from Parvinder and I to continue that. So thanks Parvinder and thanks Nicola.
And this is also Sandeep's baby.
Yeah, yes, this is my baby. So Pact Publishing, as some of you might know them, we've been working with them and collaborating with them. They have generously supported our user group. They have a few books that on Fabric and Power BI. And at the end of the session today, so still stick till the end. We'll pick one winner, and you get to choose one of the books. So we really appreciate their support here as well. This is not a marketing promotion. They genuinely want the community to grow, and they want to support our user group here. So I'm very thankful to them.
So thanks. Yeah, so just quick final few things before we hand over to Nicola. We will record this and share on Meetup in case you are not able to attend the full session. But yeah, the recording will be available. Again, please keep yourself mute. Nicola, how would you like to take the questions during the session after? What works for you?
Yeah, I'm fine. If you can feel free to interrupt me whenever
Okay.
there is a question. I'll try to also to monitor the chat, but if I miss something, please feel free to interrupt me. That's totally fine.
Sandeep stays on top of that. And if you put your question, please prefix with letter Q. And that's it. Nicola, it's all yours. Take away. Thank you.
Thanks. Before we start, just first of all, you two guys are too humble and you are community legends. We all learn so much from your materials. And once again, Sandeep, congrats. This way, I'll also tell you congrats when we meet each other for joining Microsoft. And they're lucky to have you. That's all I have to say. For all the others, hi everyone and welcome to Vancouver Fabric and Power BI user group meetup. I'm super happy to be here because I consider both Sandeep and Parv my friends. So it's like, yeah, if you are joining here and I consider them friends, I can also consider all of you as kind of friends. First things first, so this is the first time I'm doing this presentation. It's a brand new one. I never presented it. So please provide your feedback, your honest feedback. That would help me to, fine tune it, make it even better for future, and maybe help other people to get most out of it. So please feel free to share your feedback, both positive and negative. I'm totally open to hear this. As we said, if you have any burning questions throughout the session, feel free to ask them. I'll try to provide the answer. Of course, if I know the answer, if I don't know, we'll try to figure out something and maybe reach out offline after the session. And without any further talk, let's go and talk about what's in the Chief Data Alchemist playbook. Just a short introduction about myself. I'm Nicola. I'm originally from Belgrade in Serbia, but for last more than 9 years, I live in wonderful city of Salzburg in Austria. So it's 9 p.m. 7 p.m. Sorry, on my side. So good evening from Austria. You can find me on web. I'm blogging at data-mozart.com. Also active on social media, LinkedIn, Twitter. I still call it Twitter. So yeah, X. Feel free to connect if you like. I'm always open to chat and discuss everything about data. Parv and I talked a little bit before the session started. I co-authored the book Fundamentals of Microsoft Fabric for O'Reilly together with Ben Weissman. I'm also currently writing another one. Yes, I'm that crazy. Now with Shabnam Watson. You also probably know her. She's also an MEP from USA. It's about analytics engineering with Fabric and Power BI. This one is still in very early stage. We have just a couple of chapters available currently at O'Reilly's platform. Other than that, I know my friend Chu is here and he's a huge Madrid fan and we always have some internal jokes. On the opposite, I'm a huge Barca fan, as you can conclude looking at this photo, which was taken at the old Camp Nou stadium, 2-3 years ago, I can't remember. So that's about me. Let's talk about what we are covering in next, let's say, approximately 60 minutes. I'm not sure how long will it take because I'm doing it for the first time. So hopefully everything works and we are on time. Basically, we will talk about first about the Alchemist calling. So our why we are here, and what things we try to demystify. So then I will try to enclose the Alchemist formula. So talking about core Medallion principles, forging all these metals that are part of Medallion. So doing some deep dives about particular parts of Medallion design pattern and discuss some common debates that exist in data community about this Medallion approach. Then we will use Microsoft Fabric to craft Medallion architecture. Very simple example, but something that you may use as a blueprint maybe for your own workloads. And finally, how to become the Chief Data Alchemist, so sharing the playbook and wrapping up the session with some key takeaways. Okay, so first, what is a Medallion? I guess you, because you are involved in data community, you heard about Medallion, right? But let's try, just in case that some of you haven't heard about it or not 100% sure, what is a Medallion? The first question you should ask yourself is it even an architecture? And the first big debate, we will have a lot of them throughout the session, is if Medallion is an architecture at all. Now, officially, it's called Medallion architecture. And if you go to Microsoft's documentation, Databricks documentation, you will find this term Medallion architecture. But is it an architecture? I will share my personal opinion. So in my opinion, Medallion is not an architecture. It's just a design pattern for organizing the data. So we can discuss that afterwards, offline, however you want. But in my opinion, Medallion architecture is just a fancy name for a design pattern to organize the data. And if you don't trust me, this is taken from the Databricks website. So Databricks is considered a pioneer in coining this term Medallion architecture. And they say that it's a data design pattern used to logically organize the data. But this is just to open the session with something that is commonly related to Medallions and Medallion approach. There are a lot of debates, a lot of discussions, and it starts with the name. And you will see throughout the session when we cover specific parts of the Medallion approach that these debates are growing and growing, and it's not always easy to stay focused and understand really the fundamentals. That's why I thought that maybe having a session like this would make sense and would be helpful. Nevertheless, whatever I told you, this is my personal opinion. If you call Medallion an architecture, that's also fine. No one will think that you are crazy or that you don't know the things. So it's just about the namings and understanding the real essentials behind this approach. This is a high-level Medallion overview, so I don't want to spend too much time on this slide. This is taken from Databricks official documentation, and essentially it gives a very nice brief overview of what Databricks considers as a Medallion architecture. Here is the link also included. I can share the presentation, of course, afterwards, so you can go and check all of these included resources after the session. So the main question is, Medallion is very simple. You saw on the previous slide. So on this slide, you saw that it's a very simple thing, very simple architecture, unlike those complex diagrams with hundreds of services, tools, and so on. This one is very simple. There are three parts of Medallion architecture. Let's call it architecture while we are on Databricks slide. So there are only just three parts of the architecture. And the question is, why does something so simple cause so much confusion and debate? And I would say some of the most common questions, there are many more, of course, and I'm sure you will throw some great questions throughout this session. Some of the most common questions I'm hearing from people in both in community and also from customers where I work on implementing data architecture are these. So first, do I need a landing zone? You didn't see landing zone as a special part of Medallion architecture, right? There was only bronze, silver, and layer. So do I need a special landing zone, or should I apply any transformations inside the bronze layer? What is a platinum layer? Because people are reading posts on social media, and there are a lot of people mentioning platinum layer or diamond layer. What's this now? This is not in Databricks illustration, right? So what is a platinum layer? Should my silver layer be modeled as a third normal form-like tables, or just a cleansed one-to-one copy version of the data source? So those are some of the most common questions. I'm sure there are many more. But let's dive and try to understand why these questions are important. First of all, let's understand what is the problem of Medallion. I intentionally put this word problem under double quotes because, in fact, Medallion is a great concept, but it's too often misunderstood. And I think that's the main problem of Medallion. In many scenarios, they are treated as a rigid step-by-step framework when they are actually a flexible, or should be a flexible, approach to making sense of the evolving data landscape. So they're in their essence, they're an attempt to simplify years or decades of evolution and technical innovation into concepts that can be presented to non-technical users. That's the main intention of the Medallion approach, Medallion architecture, is to simplify something that already exists and already existed for years to non-technical users so that they can better understand what's really going on. But this simplification, like any simplification in life, comes at a cost. So it leaves huge gaps for debates, for misinterpretation and frustration, to be honest. Medallion in this case is a simple bronze, silver, gold conceptualization of the operating model of running a data lakehouse. This is the best possible attempt to make a set of complex, flexible, technical decisions, an easy to understand process, and prevent organizations from falling into the so-called data swamps. We have more problems with Medallion. It's not just simplicity and simplification that comes with a cost. Another problem is that people think that if they need to implement a Medallion architecture, there is a checklist with instructions and they need to implement all of these points from the checklist. This is not, of course, this is not true. It's not about taking the exact rigid process and trying to fit your organization into it. So it's the other way around. You should find a process that works for your organization. So you don't need to try to put your organization into the scope of these 3 layers that are defined within the Medallion architecture. Now the question is, what is the right way to do it? I would say the most important thing to keep in mind is the context. It's fairly easy to document some processes and technical implementations and put it out into the world and say that's the right way to do things. But that rapidly loses value if we forget the why. So we'll try to examine not just how to implement certain process, but why we need those processes and decisions we have to make along the way. Let's start with fundamentals. Let's start with explaining what Medallion in its core is. Essentially, as you saw in that Databricks slide, there are 3 layers in Medallion architecture: bronze, silver, and gold. That's why it's called Medallion, right? And you will also hear many other terms outside, like raw, validated, enriched, or raw, validated, curated. So there are many synonyms for this bronze, silver, and gold, but the core idea is the same: to have different logical layers of data in the lakehouse that are of different quality and serve different purposes. So let's quickly examine these 3 layers. First is bronze layer. That's where we land the data from external sources in its original raw state. In most cases, that's a small spoiler, because in some of the next slides, I will show you some exceptions to this general rule or general recommendation. Here, data is ingested as is, containing only metadata in addition. The purpose of the bronze layer is to serve as a repository of the historical archive of source data, so you can quickly reprocess that data if necessary without needing to connect again to multiple disparate data sources. It's important to keep in mind, this is the key thing that defines bronze layer, that it contains unvalidated data. In regards to storage format, depending on the scenario, the bronze layer may store the data in its original format, be it a CSV, JSON, XML, or some other fancy type. Although Delta or Iceberg, depending which provider you're using for storing the data, so which lakehouse you are using. So storing the data in the lakehouse native format is something that you should try to do if possible. Then we have a silver layer. Silver layer data, we take the data from the bronze layer, we conform that data, we clean the data, so that all the key business entities, concepts, and transactions are available in the form of the so-called enterprise view, which is already ready for ad hoc analysis, machine learning workloads, and so on. In this stage, data is enriched and validated. So this means it can be trusted downstream for further analytical workloads. From a data modeling perspective, the silver layer contains either third normal form like tables or follows the bronze structure. So we will discuss these nuances later in the session, but in most cases you will find silver layer modeled either as a third normal form relational style database or a simple copy of the bronze layer with cleaned and validated data inside of it. And here data should be stored in lakehouse native format. And finally, we have the icing on the cake, which is the gold layer, where data is structured and organized to support specific project requirements. This means, because this is the final stage in this entire process, data is additionally refined and cleaned. And here you will also go and apply various complex business rules, business logic, use case specific calculations, and so on. From the data modeling perspective, the gold layer is usually implemented through a Kimball style star schema. I hope you all know what's star schema and who is Ralph Kimball. If not, sorry, it's out of the scope of our session today, but we can talk again offline if necessary. So in most cases, although I'm seeing also out in the wild, I'm seeing people using one big table also as a gold model, depending on the tool that is used to consume the data from the gold layer. In most cases, still star schema. And this is non-negotiable. Data must be stored in, must. Nothing in life should be labeled as must, but at all costs should be stored in the native lakehouse format because of, multiple different reasons. Now let's lay the groundwork. Before building a house, so we learned some basics about Medallion architecture. Now it's time to dive a little bit deeper and understand some nuances that might affect your choice about or decisions that you will make while building each of these layers. So the same idea as for building a house applies to the Medallion approach. And before diving into explaining Medallion in more depth, let's understand some key concepts that are tightly related to building the Medallion architecture or Medallion pattern. So we will discuss extra landing zones. I already mentioned that as one of the most common questions. This is kind of a preliminary area where raw data is ingested before it lands into Medallion. Raw data that represents the unprocessed data collected from various sources. Batch processing as a method of processing the data where the data is collected and processed in batches at scheduled intervals. Stream processing, where the data is processed as soon as it becomes available. And finally, ETL and orchestration tools, which are integral part for moving data through different layers or stages in Medallion. So let's start with extra landing zones. A landing zone is often used as a preliminary area where raw data is ingested before it lands in the Medallion. Now, should you use or skip the landing zone? Well, it depends, of course. Various factors will influence these decisions, like characteristics of the data source. I'll give you a very simple example. When dealing with external services or software as a service vendors, you might need a secure landing zone to initially store data before moving it to the bronze layer. Similarly, certain application teams will, with strict data ingestion requirements, may force you to use own dedicated landing zone. These teams manage the extraction process, ensuring there are no unexpected errors or data inconsistencies. While the bronze layer mainly serves as the area for data collection, you may need this extra preliminary landing zone in larger or more complex environments. It's up to you to decide whether to label this layer as a bronze. Some organizations might call it a thin layer or pre-bronze or pre-refinement, staging, landing. There are a whole variety of different namings, and place it outside the typical Medallion setup. Others might include it in the bronze layer design as a substage. This means an extra landing zone is, as its name suggests, an extra layer, so use it only when it's really needed. Now to discuss about raw data. When talking about collecting the data and landing it in the bronze layer, we tend to use terms like raw or as is. But we have to be careful with this calling data raw or as is. With this, and not take these terms for granted. Before I provide you with a couple of examples, let me first state this clearly and loudly. Data pre-processing is not the same thing as data transformation. Let's consider a complex transactional systems that involve vendor packages with thousands of tables. In these cases, an engineer might need to step in and perform the mediation during the data extraction process. To illustrate this, some data sources are specific softwares, like banking software, for example. And in certain scenarios, data is stored as an XML file, which consists of only two columns: record ID, which is a primary key, and the XML record itself. If you try to extract this data directly, you would end up with a very complex and hardly manageable data set. So you may consider using some additional tools to pull that data and store it in a more manageable structure. The same applies to complex ERP systems with thousands of specialized and interconnected tables. I'm sure you know what I'm talking about, whoever worked with an ERP system in the past or right now. And this is a serious challenge when you try directly to extract this data. To cut the long story short, in some cases, the first step from technical system tables to ingestion sometimes may involve a middleware or custom-built software component, which job is to make these complex system tables or proprietary data structures into a simpler and more manageable data model. The next thing we are discussing is understanding the difference or requirements with stream versus batch data processing. To put this discussion in the proper context, let's briefly demonstrate the key differences between stream and batch data processing. So we'll kick it off by examining how batch processing works. In real life, data may come from different sources at different points in time and so on. So let's say that our first chunk of data just came in. Then the second chunk arrives. Then the third, the fourth, the fifth, and so on. So what we are doing in this batch processing setup, we will wait for all these chunks of data to come before processing them at once as a whole or as a batch. That's why it's called batch processing. Now let's see how the same scenario is implemented in a stream processing setup. Again, our first chunk of data arrives. However, instead of waiting for other chunks of data to arrive, we will immediately process the data chunk number one. Then when the second data chunk comes in, it's being processed as soon as it arrives. And the same happens for any of the following data chunks that arrive from the data source. So this is the difference. Based on these requirements, you may want to structure your layers in a different way. Again, we will examine this later. This is just to put a discussion about various types of data processing in the proper context. Discussing the tools for extracting, transforming, loading, and orchestration is crucial because it can significantly influence design of the process of building a Medallion architecture. So let's briefly introduce some of the available and mainstream options on the market. Of course, there are hundreds of tools that you can use for ETL and orchestration, but I want to just point out a couple of those that are considered most widely adopted and used. So first we have Apache Airflow, which is an open source platform that allows you to programmatically author, schedule, and monitor workflows. It's also available in Microsoft Fabric. Then we have Azure Data Factory, which is also widely used among organizations that have adopted Microsoft's data platform. It is effective at creating, scheduling, and orchestrating data workflows. Within Microsoft Fabric, Azure Data Factory has its, let's say, successor, which is called Data Factory. So just without Azure prefix, very creative from Microsoft, but yeah. But functionality largely remains the same. So if you work with ADF, then you will feel at home with Data Factory in Fabric. Then coming to another vendor, which is Databricks, we have two mainstream options: Databricks Autoloader and Databricks Workflows, which is a managed orchestration service as part of Databricks platform. When it comes to Microsoft Fabric specifically, ETL and orchestration tasks are performed using the workload that I just mentioned a couple of seconds ago, Data Factory workload. And if you're wondering Where did I get this amazing icon? It's from Excalidraw, fantastic tool for building all your illustrations, diagrams, and so on. There is a built-in library. I think it's developed and maintained by Miles Cole. He's Sandeep's colleague from Microsoft, and it's amazing. I really prefer using those icons to the official ones. Going back to which tools we have available, so you can choose between a no-code transformation tool, such as Dataflow's Gen 2, a code-first solution using Fabric notebooks, while orchestrating all of these, plus potentially many more activities, except these data flows and notebooks, is done through the Fabric pipeline. We'll build a pipeline in demo, I promise that. Okay, now that we laid this solid foundation, let's dive into some of the nuances of the Medallion pattern implementation. So you heard already a couple of times and in this session and before this session that Medallion has 3 layers, right? Despite the popularity of this 3-layer design, there is a significant debate about the scope, purpose, and best practices for each layer. Moreover, the gap between theory and practical application is humongous. But let's first discuss the key purpose and functions of each layer from a high-level point of view. In this illustration, I'm using the extra landing zone for blob files and Apache Kafka storage. First, in a bronze layer, we already said that's the initial landing zone for raw data collected from various sources. Then in a silver layer, we refine, we clean, we standardized raw data, preparing it for more complex both operational and analytical tasks. We'll examine what goes into silver layer, so I will just stay here on a high-level explanation, and gold layer, which delivers refined data optimized for specific business insights and decision making. Again, we will talk what goes into gold layer, but you can think about operations like aggregating data, summarizing, enriching data to support high-level reporting and analytics. The most important thing, or one of the most important things, is to set our mindset right about the Medallion layers. It's crucial to think about these layers as logical, not physical. So when talking about, for example, the bronze layer, don't frame it as just one physical layer. Instead, try to think about it as a logical layer that could span across several physical layers. That's one of the key takeaways, I would say, from this session. Now let's dive and understand how to design each of these layers. Obviously, we are starting with the first one, which is a bronze layer. And when we are designing a bronze layer, the main thing, the main debate that pops up is what belongs to bronze? Is it more than just raw data? So what belongs to bronze? Is it more than just raw data? The short answer is yes. You should always add ingestion metadata. At a minimum, capture the source file name or topic, timestamp of when you loaded it, and unique correlation ID for the ingestion job. How does it look in reality? Let's say JSON file is our data source, and this JSON file contains the information about order ID, amount, and quantity. So when you load this data into a bronze layer, enrich this file with metadata. What is the name of the file? When did you load it? Correlation ID, so you can refer back when needed, and so on. So this is how bronze layer should be structured. So bronze layer is not just a pure I brought data from somewhere and drop it in the lake house, and this is my bronze layer. You should add metadata to it, then it's considered a bronze layer. Okay? Whether the bronze layer consists of a single physical layer, remember we talked about bronze layer as a logical layer that may consist of multiple physical layers. Now, whether this layer consists of a single physical layer or multiple sublayers depends on the complexity of the data sources and obviously the organizational needs. Let's imagine the following scenario. Traditional source systems often determine in which format data must be exported, and it's typically something like CSV or JSON. Consider also a legacy application that exports data only to a local file storage location. And in this scenario, you would integrate the data into your Medallion architecture through batch processing. And here is a typical processing workflow. The process begins by staging the data in a landing zone where you perform minimal processing tasks, such as decompressing zipped files, comparing checksums, and generating metadata. Remember, data processing is not equal to data transformation, right? Following this, you copy the data to the bronze layer, converting it into a format like Delta Lake or Iceberg. So talking about Microsoft Fabric into Delta Lake format to enhance performance. At this stage, you also carry out basic validations to ensure data integrity. Optionally, you might also classify or encrypt the data to protect sensitive information when the data goes downstream to the silver layer. And finally, you compare and integrate data with your existing bronze data sets in order to maintain consistency and completeness. In this data processing hierarchy, the bronze layer often includes multiple sublayers, an internal staging area, processing and refinement area, and eventually storage in Delta format. So whether the bronze layer is a single physical layer or multiple sublayers depends on data source complexity, organizational requirements, and decision on whether to include the landing zone as part of the bronze layer. We'll discuss some use cases afterwards, but the main thing to consider here is what is your data source complexity. I'll give you a simple example. If your data source is SQL Server database, then you don't have this level of complexity like when you need to transform, for example, JSON file. We will do JSON transformation in our demo, but it's something to keep in mind when you are designing your bronze layer and how it will be implemented. The next thing to keep in mind is data historization. The bronze layer is designed primarily for storing complete snapshots or copies of data, similar to what you would find in a staging environment in traditional data warehouse systems. So this layer is especially useful if your method involves fully extracting and overwriting data, because it allows you to maintain really a comprehensive history of all data deliveries. In a Medallion architecture, archiving data is straightforward when you use the efficient storage format like Parquet or Delta, and then organize this in folders. However, it's important to note that the bronze layer is not intended for historization of data in the sense of representing a fully processed, slowly changing dimension 2 table. Again, I hope you all know what slowly changing dimension as a concept represents. It's out of the scope, but keep in mind that bronze layer is not intended to do this type of historization, right? As businesses grow and data sources are frequently updated, the database structure or database schema can change. And this evolution can lead to inconsistencies in data processing. This means it's essential to manage schema changes effectively. The bronze layer is crucial for managing widely varying and ever-changing data schemas during the process of data, when data enters the system. When managing schemas, organizations face two main design choices, each with its own approach to schema changes or schema evolution, how it's called. The first one is schema on read. This method applies the schema dynamically as you read the data. With this, data is stored without a strict schema in place. The schema is only inferred or applied when the data is accessed during processing, during the reading process. This flexible approach requires the system to recognize and possibly adapt to various data schemas right after the point of ingestion. This approach is particularly useful for semi-structured or unstructured data, also for structured data that comes from data sources without any built-in schema enforcement, like CSV or Parquet files. Another one is schema on write. Schema on write involves defining the schema, like the table, column names, data types, primary keys, and so on, as you write the data into storage. With this method, you must define the schema upfront, making sure that the data conforms to this schema right from the start, before you write it into your lakehouse. It's a more rigid approach compared to schema on read, obviously, but it's generally used for structured data. When using Delta Lake, if there is no predefined schema, what is going to happen? You probably realize that if you already work with Fabric, the system will establish an initial schema by using the struct type from the data frame that is being converted to the Delta table. Of course, sometimes it's okay to do that, but in most cases, especially for analytics, we really want to have a proper schema in place. In the bronze layer, schema on read is a common approach where data is stored in its original format without enforcing a schema during ingestion. Some of the considerations, if you go with this schema on read approach for your bronze layer, first, relying solely on schema on read does not allow for blind data processing. You may need to detect and log schema changes, handle failures, restore data using Delta Lake's time travel feature, or add some schema-related metadata. So those are things to keep in mind when you are designing schema on read approach inside bronze layer. Also, defining a data update method is essential, especially for data historization that we previously mentioned and data integration. So some of these options include continuously appending to or merging with existing data sets, overwriting them, or applying time-based partitioning.
Hey, Nicola?
Yes.
Yes, we have a couple of questions. You want to take them now while you're on bronze?
Yes, sure.
Okay,
Do you want me
awesome.
to read them or?
No, I'll read it to you.
Okay,
So for the
perfect.
first question is from Vikar, but his question was, should the data retention for raw is all history? How about silver and gold? So he's wondering, the data retention is the history is done in the raw, but should we also have history in silver and gold? And Vikar, please feel free to unmute yourself if you have any clarifying questions or if you want to add anything to that.
Okay, if Vikar doesn't unmute, I will try to quickly answer. So,
yeah.
Generally speaking, the only correct answer is, again, it depends. We will now examine what is the purpose of the silver layer and gold layer, and then based on its purpose and your requirements. So, do you need to perform any kind of analytics on all historical data? In that case, yes, you will probably keep all the historization also in silver and gold layer. If not, and in most cases, I would say in most cases, silver and gold are not preserving the full history. There are exceptions, of course, but yeah, that's short answer.
Perfect. Next question is again from Vikar. What are the pros and cons of using 3NF in silver? And are there the pros worth spending the compute, ETL, dev time, batch processing time required for referential integrity in 3NF in an enterprise setup?
This is a great question. Whenever I said this is a great question, answer comes in one of the next slides. So just be patient a little more, and I hope presentation will provide the answer. If not, I'll come back to address it. So yeah, we'll talk about these potential scenarios. Yeah.
Okay. And the last question before we move on from Jason: should there be any deduping done in the bronze?
Again, it depends. So yes, if you want to start deduping data in bronze, that's absolutely valid approach. But I would say if you want to keep it strictly as a one-to-one copy of your source system, leave it as it is. it's a recommended practice to do all these data cleansing in the silver layer, not in the bronze layer. So the bronze layer is really meant to be like a one-to-one copy of your original data, but if possible in some more optimized storage format. But don't do data transformations inside bronze layer. In most cases, again, it's nothing is set in stone. Whatever you hear from me here, it doesn't mean that you should go and apply it to your organization tomorrow and that it will work perfectly. No, we are just considering different options, different approaches, and I hope I provide a food for thought for all of you when you consider building Medallion approach. So to answer Jason's question, I would do deduplication in silver layer.
Perfect. Thanks, Nicola. We can move.
Okay, awesome. Thanks, Sandeep. Thanks, everyone. Great questions. So yeah, keep them coming. Okay, let's move on to talking about. So let me just. I lost my Teams. Okay, I'm here. Everything looks good. Cool. So technical validation checks based on Jason's question. Let's go back and now understand, because technical validation checks are crucial, because issues with data integrity, data accuracy, completeness, and consistency may have significant operational and strategic impact on any organization. Within the lakehouse architecture, the bronze layer acts as the initial repository for raw, typically unstructured data. Here, data is stored in its native format, or, as I said, just processed to be stored in a more suitable storage format, but without any changes. Only validations that we are using are validations for things like format, schema, and data completeness. This is very important because it ensures that the data conforms to specified standards within the organization. And again, it helps maintain consistency across the data set. Early validation helps us to identify and address data integrity issues as early in the process as possible. It's particularly useful when you are applying schema on write approach. By catching these errors as soon as possible, it prevents the propagation of inaccuracies to subsequent layers where data is further processed and refined for analytical purposes. You have different options here to perform these checks. You can perform these checks in one go, you can break them into segments, or you can integrate them during data transfer to the silver layer. So there are two types of checking this data integrity, intrusive and non-intrusive. Unfortunately, we don't have time to explain the difference between these two. Again, if we have enough time by the end of the session, I'm happy to talk about this. Okay, let's move on to the silver layer. Still a lot of things to cover, and demo is also waiting for us. So the silver layer focuses on cleansing and enhancing the data. So here the formats are standardized for elements such as date and time, reference data is enforced, naming standards are conformed, duplicates are removed, and series of functional data quality checks are conducted. Additionally, low quality data rows are discarded and irrelevant data is also filtered out. Most importantly, at this stage, data, generally speaking, isn't yet merged or integrated with data from other sources. So if you have data coming from multiple different data sources, usually you don't do merge or data integration of this data coming from different sources in the silver layer. Usually no. What are the most common cleaning data activities that we perform in the silver layer? First, reducing the noise and removing inauthentic data. That means eliminate irrelevant data such as unnecessary columns, unnecessary rows to enhance the overall data quality. Handling missing values. Now here you can decide what to do with these missing values. Do you want to remove them? Do you want to replace them with something? Or do you want to do something like estimate missing values based on surrounding data? Those are three options. Removing duplicates. Verify that your data set is free of duplicate records. unless specifically required. Let's say for retention compliance, for example. Trimming spaces, error corrections like typos, incorrect capitalization, and so on. Consistency checks like abbreviations, terminologies, units of measure, and so on. And standardizing formats. So ensure that date formats are consistent. For example, if you want to use US style format or European style format, this is done, this type of cleaning data activity is performed in the silver layer. Now there are more to that. We are also correcting data types. We are fixing data ranges, fixing data uniqueness so that data maintains uniqueness wherever it's required, fixing constraints, masking sensitive data if you deal with sensitive data, perform anomaly detection, and of course, many, many more. But these are like, let's say, a set of most common data cleaning activities that you should perform inside the silver layer. And as I said, this list is not meant to be exhaustive. And usually it requires deep understanding of the data and business processes that generated the data. So it's also highly dependable on the organization itself. Now going to the question that we are asked, how do we model the data in the silver layer? Because we now clean the data, what is our next task? Should you retain the data in its original structure, cleaned, refined, and so on? Or should you remodel it? Let's explore these questions. And this is one of the hottest topics, I know that, because there are many possibilities, and it is significantly influenced by the number of data sources collected. So first things first, in Medallion architecture, it's common for the silver and bronze layers to align as a straight one-to-one in terms of their tables. Though the way the data is presented in this layer, in these layers might be different. So this is one-to-one, keeping one-to-one structure of the bronze layer. So what I'm doing here, I have a very simple SQL query where essentially I'm taking data from the bronze layer, table in the bronze layer, and as you can see here, I'm properly naming my columns. I'm performing some simple data transformations. And yeah, if you expose the data to in silver layer or even worse in gold layer to your end user as RGCD, what the hell is that? So this is region. So you do things like that here. And you keep your data stored the same in the same structure or the same granularity as your bronze layer. It's just cleaned and conformed, nothing more than that. Another option is to perform denormalization, or basically create a third normal form style of organizing data in your data storage. In this case, essentially what we are doing, we are creating a third normal form like tables, and whenever you need to obtain the data from these tables, then you need to perform kind of, you need to perform kinds of operations like joins to bring the data from multiple tables. So what are the pros and cons? Obviously, the main downside of creating third normal form like model is it requires more time and more effort. Also, in many cases, it will also require more space, depending on the size again, and so on. But the main downside is it requires more time and effort. Again, if your silver layer is meant to be used for ad hoc queries, then it might make sense to create third normal form, especially if your consumers are familiar with writing SQL language of any dialect like T-SQL or Spark SQL. So in those cases, it makes sense to create third normal form. Other than that, I would say keeping the data as a one-to-one copy from the bronze layer, just with cleaned and standardized information inside of it, in most cases makes more sense. Again, this is my personal opinion. Another thing to keep in mind when you are building or modeling silver layer is the concept of how do you handle slowly changing dimensions. Now the question is often, do I build slowly changing dimension in silver layer or gold layer? Again, it depends. So if you have users that will query the data from the silver layer, then slowly changing dimensions should be implemented there because they are tracking all the historical changes. And here we have three main concepts to keep in mind: business key, surrogate key, and hash as a value that is generated from input data of arbitrary size using some hashing algorithm. And this unique result or hash value is then used as a digital footprint of the data. Okay. So third normal form versus keeping the bronze structure. Try to understand all these things that comes with third normal form. I know that most of people are familiar with building third normal form data models. In such cases, this requires time and resources and is usually more complex to implement. Medallion simplifies data reloading from bronze. That's also something to keep in mind. So think about what is your priority. Once again, there is no single correct answer here. Think about your priority. So is it strict data normalization, enforcing integrity between those tables, or simplicity and speed of creating your silver layer? Moving to a gold layer and then demo. Oh, we are over time. I hope you will. Is it okay?
Going.
Okay.
Yeah,
Okay. Awesome.
keep going.
Thanks.
Yeah.
Okay. Thanks.
Gonna take a couple of questions here.
We can take them now. Yeah.
Yep. Okay. So first question is from Scott. Question about backups. What should we do for a DR, which is disaster recovery for analytics platforms? What are people out there doing? Keeping the historical imports makes sense, but do we back up the data in silver and gold, or just the code in Git repo, one-time snapshot that can be kicked off to recreate the environment? So basically, I guess summary is, should we consider DR for all the layers, or how do you do that?
Yeah, that's a great question. So I would say you don't need to back up silver and gold layers because data can be easily reprocessed. Once you have it in your bronze layer, definitely you need to have a backup of your source data somewhere because you don't want to lose it. Essentially, backupping of silver and gold layer wouldn't make much sense, although we know storage is cheap and so on. But since we have so many powerful tools for data processing nowadays, it's really not worth taking care of these backups of silver and gold layers because you can easily reprocess them if necessary from the bronze layer again.
Okay. For a question from Tracy, is it better to merge the data from different sources in the silver layer, or is it in the bronze layer? I think you touched on that, but just wanted to raise it again.
Yeah. Not bronze, not silver. Merging data from different sources should happen in gold layer. So silver layer, you should clean the data per source, but you still don't merge. You still don't create this enterprise view in the silver layer because of the potential backward complexity. If things go wrong, then it's hard to decouple things that are merged in the silver layer. So in the silver layer, we still consider one data source as an atomic unit. So we keep all these things, all these processing pipelines separately. And then in the gold layer, to create this enterprise view, we merge those different data sources.
Awesome. Perfect. Let's keep going.
Okay,
and take your
thanks.
time, Nicola. No worries. We can go over time. So
Okay, yeah, sorry about that. So I definitely need to.
Not at all. Yeah.
Yeah, it's the first time, so please
No. Keep going. Keep going.
excuse. Yeah. Okay.
Yeah.
So gold layer is when we introduced the overall structure of the medallion approach. I will ask you. You think that gold layer is the easiest one to build, right? I mean, from a logical point of view. So the hardest things happen inside the bronze layer and silver layer. And gold layer is, let's build a star schema and we are ready to go. But it's not that easy. There are many nuances. First of all, depends on how many different source systems you have. And sometimes it can be a very daunting task based on Tracy's question. Merge all these into a single harmonized view. This layer incorporates numerous complex business rules and business logic, and also some post-processing activities like calculations, enrichments, application-specific optimizations, corrections, transformations, aggregations, and so on. In most cases, star schema in gold layer will probably address most of your needs. When you design star schemas, remember that their role extends beyond just boosting performance. It's also that they are shaped to allow users to easily interact with data. Loading star schema involves two primary tasks: loading dimension tables and loading fact tables. When we talk about the loading dimension tables in star schema, it's just enough to say that you need to take care of slowly changing dimension, which is an incremental process that involves comparing incoming data with the existing data in the dimension table. Also, it's essential to harmonize the data before inserting records from or into dimension tables. This is usually a multi-step process that requires careful planning, and it's not so straightforward always to implement. Loading fact tables in a star schema, while seemingly simpler than loading dimensional tables, still has its own challenges. The primary task here involves replacing the business keys with surrogate keys, which are linked to dimension tables. Each row in the fact table includes foreign key references to rows in the dimension table. And during this loading process, you might encounter situations where certain relationships between dimensions and facts in the tables cannot be established. This is what practitioners call early arriving fact. In those cases, creation of placeholder records becomes necessary. So these are typical dimensional modeling considerations and things to keep in mind. Okay, while implementing this star schema with facts and dimensions is very popular strategy for gold layer, they can become increasingly complex sometimes because dimensional model expand, you have new data sources to incorporate and so on. This growth often results in overlapping requirements that are similar but still distinct enough to require different design approaches, potentially altering the design of the gold layer and sometimes even the silver layer. For example, some organizations might add these extra conformed or extra curated layers with separate semantic layers for data marts that use star schemas. Occasionally, these additional layers are called platinum layers. So when you hear someone talking about platinum layers, this is just another step in refining the data from the gold layer. The idea is to highlight this highly specialized and refined nature of the data. Again, this is something same as for extra landing zone. It adds complexity to the overall structure and should be carefully evaluated. Do you really need this or not? So don't jump in the wagon following all the trends. Carefully evaluate if you really need it. So it depends on size of the organization, number of source systems that you need to integrate, and specific semantic modeling requirements. Another option when designing a gold layer, and I see this very popular, I'm quite surprised because of that, but I see that it rises in popularity. Designing star schema is obviously beneficial, very beneficial. That process of designing star schema is also effort intensive. Consequently, some organizations prefer to implement a one big table approach due to its speed and simplicity, which can outweigh considerations of model flexibility and extensibility. One big flat table or one big table involves storing all the data, as its name suggests, in a single large table. This method avoids distributing data across multiple tables or organizing it according to more complex schemas. Some of the advantages of this approach. First of all, it's easier to manage, let's be honest. In some cases, it can provide better performance compared to star schema. Those are rare cases, but if your organization has that use case, for you, maybe it makes sense to consider it. And it's also preferred by specific data professionals like data scientists and machine learning engineers who expect data in one flat format. So if you build your Medallion architecture to support a large number of data scientists and machine learning engineers, this approach also may have sense. But despite all of these advantages that I just mentioned, I believe that proper star schema design should still be favored over the one big table approach for the gold layer, especially considering downstream data consumption using tools like Power BI. We all know that Power BI loves star schema. Before demo, this is the last thing. I walked you through a simple example where we'll use the same data pipeline for imaginary company, imaginary retailer company. So we have the standard domains in retail industry, customers, orders, products, and we want to move them through a Medallion flow. First, the bronze layer is a few change data capture streams from the OLTP database, database streams, and so on. Here we have a table called, for example, orders_row, which includes duplicates, late arriving records, and also soft deletes. Next, the silver stage contains the cleansed and conformed tables from orders_row. In this case, I'm creating a third normal form style data model. So we have tables like orders clean, where order line, we have a data on order line grain, data is deduplicated. We have customers clean, we resolve business keys and so on. And we have products clean, for example, typed attributes and so on. Finally, we have the gold layer where we can take our pick of modeling approaches like star schema. We already mentioned that. So we can have fact orders. We can have dim customer table that is implemented as a slowly changing dimension type 2 table, or dim product as slowly changing dimension type 1, which are optimized for typical BI slice and dice scenarios. Or one big table where we have orders enriched with 85 flattened attributes for a specific dashboard with fixed questions that don't change too often. And one last thing, yeah, I told that previously, but I forgot about the workspace design because, yeah, we talked about Medallion. Now it's also important to understand how do I build this thing in Microsoft Fabric. So we are now talking specifically about building Medallion inside Fabric. How do we structure our Fabric environment? I will assume that you know what Fabric is. If you don't, I have to disappoint you because, yeah, explaining Fabric is out of the scope of this session. However, since we are talking about the workspace organization, I'll just briefly introduce the concept of the workspaces. In a nutshell, a workspace represents the container for storing various Fabric items. Think of notebooks, semantic models, lakehouses, pipelines, warehouses, and so on. The main purpose of the workspace is to enable collaboration between multiple individuals and teams inside the organization. So now that we know what a workspace is, the next set of questions might be, should I place all of my Medallion layers in a single workspace? Or should I maybe have a separate workspace for each layer? Again, there is no single correct answer, so let's examine our options. If you follow Microsoft recommendations, you'll create something like this. Microsoft recommends creating each lake house in its own separate workspace. So we are talking about this one here on the right. This is Microsoft's recommendation. As Microsoft states, this approach provides you with more control and better governance at the zone level, which is true, but it may also introduce additional complexity and overhead especially for CI/CD workflows. Imagine that you have a separate workspace for each Medallion layer, and then you have a dev test and prod environment. This is already 9 workspaces to manage and to take care of, which may be a little overhead in many scenarios. So I would say And I would strongly encourage you to read the article written by Will Krager. Here is the link. It's called Microsoft Fabric Enterprise Deployment Considerations. Honestly, this is my go-to resource whenever I'm asked about structuring workspaces in Microsoft Fabric, because it provides a really comprehensive overview of different scenarios and use cases. To wrap up this part, so Microsoft recommends using separate workspace for each layer. From my experience in practice, it's better, or let's say it's less complex, and for most cases it's completely fine to have one workspace and just separate lake houses for each of the layers. Finally, we build a thing. So here is our scenario. We are connecting through the API to the repository that contains all the earthquake data from around the world. This is inspired by the YouTube video I found somewhere. I forgot the name of the guy who did it. But basically, I took this and applied some changes along the way. And we moved this data from earthquake repository through our layers. So we are refining it gradually. So let me go and open my Fabric workspace. I'm in the Fabric workspace. I already prepared some things in advance. So you see that I have a workspace called Medallion, and I have lake houses. So let's click on lake houses just to show you what I have here. I have 3 separate lake houses: bronze, gold, and silver. They are completely empty right now. So we will populate them in the demo. But in this case, I want to show you what we have as our starting point. Also, what I want to show you, this is the API documentation for this earthquake thingy. This is how the query should look like. So there you can check what are the supported parameters. In our case, it's just start time and end time. This is something that we are going to use in our demo. Going back to Fabric, and I'll open notebooks. Based on notebooks names, you can assume what we are going to do in each of them. So the first one is bronze load. So we need to load the data. As you see, currently nothing is stored inside the lakehouse. So I will just collapse here quickly. And let me show you how this looks like. So I'll unfreeze that. That was frozen because of pipeline later that we are building later. So it will take a couple of seconds, hopefully, yeah, a couple of seconds to spin up the Spark cluster in the background. So what we are doing here, I built API URL using some fixed parameters, those that were shown in the documentation itself. So I'll freeze this and show you how the response look like. So you see, it's a JSON format. So data is nested. It's not readable, right? So you can't push this JSON file to your data analyst and say, yeah, what is the maximum magnitude of the earthquake somewhere? So this data needs to be transformed. That's what we are going to do. If you want to pick only a certain type from your JSON file, in this case feature, you can run something like response.json and then features. We have a couple of issues here. You see that time is a big integer number. So essentially this is Unix timestamp format, which is the number of milliseconds or seconds, I'm not sure. I think it's milliseconds since January 1st, 1970. And now so I also need to do this. In real life, we are going to pass our parameters dynamically. So you see that in my main code cell, I don't have hard-coded values for start date and end date, because the idea is to make this process scalable and fully dynamic. So essentially, these 2 parameters will be dynamically passed directly from the pipeline that we are going to build later. Just for the showcase here, I want to create these 2 parameters in the cell above. So I have parameter start date and end date, and you see the values. So I'm going 7 days before today's day. It's 18th of September. And I want to go, my last load date will be yesterday, so 24th of September. Now, if I go and execute this cell, this should create a file called earthquake start date. It will take the start date value, and then append it with earthquake underscore data and JSON. And I want to store this at the following path. In this case, I'm using a default lakehouse. In case you want to store it somewhere else, just simply go to files, and then you can copy file API path, just to show you what I'm talking about. So you see here that once I did it here, it's essentially this part of the path here. Okay, so you can provide that when necessary. In this case, I'm storing it in the bronze layer, so bronze is my default lakehouse for this notebook. I'll simply execute this cell and wait for a couple of seconds. Let's now refresh our files area, and here is our earthquake data. Okay, so in this case, I was using write mode that if file doesn't exist, I will, or my pipeline will create it. If the file already exists, it will overwrite the existing file. So this is how we do things in bronze. The next, because now we store the data from API call, we store this data as a JSON file in our bronze lakehouse. Let's go and open the next one, which is the silver notebook. So it's called silver process. I need to load a couple of built-in libraries to use them with PySpark. Again, we need to wait for session to start. Okay, and then since I don't have start date value, let me quickly create it. So start date equals, so we need to use today minus time delta, and we want to go 7 days in the past. So I'll just create this just for the sake of this this showcase in this example. And once I do that, I'm creating a data frame which will now break down the JSON values into a tabular format. We are still not there, but we are slowly moving through increasing the quality of our data for analytics. If I click here on geometry column, this first value, you can see that this is coordinates is the nested element in the JSON file, and it contains latitude, longitude, and I think this is elevation. Also, if I go to properties, there are a lot of properties here. Some of them we'll use, some of them not. But now we are at least at the tabular structure. Now, essentially, what we need to do is to reshape this. So I will reshape the data by extracting and renaming key attributes for further analysis. Remember, in the silver layer, we are doing this data cleansing and data conforming activity. So what I'm doing here, basically, I will using get item method, I will extract these 3 values that I've shown you inside the coordinates element of the JSON file and give them proper names. So longitude, latitude, and elevation. Then this sig and meg, this is not good for your end user. So I want to ensure that these columns have proper names. So like significance, magnitude, and so on. So let's do this quickly. And let's display the results of the data frame. Now we are talking. So you see that this looks almost like a very suitable table for doing some ad hoc queries, right? So we have data properly structured, properly formatted, properly shaped, so that our, let's say, data scientists or machine learning engineers can immediately start working on it. Or let's say almost immediately, because this time portion is still a little bit awkward. So the next thing we are going to do is to convert time and updated columns from milliseconds, Unix timestamp, for easier datetime manipulation. So I will do that quickly. And then let me show you again our data frame. Now you see that time and updated are in proper format. And finally, let's create our silver table. So what we are doing here, we are creating a delta lake table called earthquake underscore silver. So I'm taking the data from the data frame and using append mode, creating table earthquake silver. Once it's done, I'll show you a table here in the lake house. So we know that it worked. After demo, we just wrap up the session. So sorry about going over time. Okay, and if I go to tables and refresh this, here is our earthquake silver table. Now there is another notebook called Gold Serve. I won't run this because I'm using the custom environment here called Medallion, because I need to import some external Python libraries to create a function that helps me to enrich my data. So I will just talk what's going on here. So essentially, I'm creating a function that will extract the values from a latitude and longitude and convert that to a country code. So once I do that, once I create and register this Python function, I can use Spark SQL, for example. This is just to showcase that you can combine multiple different languages for data transformation. And I would create a new table called Earthquake Gold, where essentially I'm performing additional data enrichment. So this is my business rule, which says whenever significance is lower than 100, then I want to label this record as low. When it's between 150 or 500, then it's moderate, else high. And also extracting this country code based on the latitude and longitude. Again, we are using this dynamic parameter. Again, this would take a lot of time to spin up the cluster because we are using custom environment. So I'll skip this. And the last thing I want to show you is how to automate this entire process, because I was showing you here clicking and executing these cells. For orchestration, the most suitable tool in Fabric platform is called Pipeline. So I'll go to my Medallion workspace and I'll create, let's click new item and let's search for a pipeline. So yeah, I won't waste time with renaming it. Of course, you should always give proper names to your Fabric items. But in this case, just for the sake of time, what I'm going to do, I want to show you how to leverage some built-in functions in Pipeline to dynamically generate the content. So what I'm going to do, I will find my set variable activity, because I want to check some things before I run my notebooks. So I'll go to settings and then I'll create a new variable. So new one, I'll call it start date. It's of type string, that's okay. And once it's here, I can provide the value. I can hard code the value, but in this case, I want to go with dynamic content. Within the dynamic content, you have a whole set of different capabilities. Under functions, again, a lot of different built-in functions. In this case, we are manipulating dates, so I will expand date functions. And the first thing I want to use is add days. So add days function allows you to go back and forth, future and past, and check what's happening. So we want to go one for our start date. We want to go 1 day back. So UTC now, which will return the current UTC time, and then go to -1. Once I do that, let's quickly run this pipeline just to see what is the output. So this is just checking what the values what the values will return by pipeline before we include our notebooks. So hopefully this will not take too long. Okay, it's queued. Okay, it succeeded, obviously. And if I go to output, let me zoom this a little bit. So it goes to yesterday. And since it's 8:26 p.m. on my side right now, so UTC is -2, it's 6:26 p.m. yesterday. So essentially this is okay, but we need just the date, not also the time portion. So I'll go back to my set variable and adjust the formula that I'm using here. So again, I'll go to functions, date functions, and I want to format my date time. So I'll still use this add days and UTC now block, but in this case, I want to format it as year, month, and date. Okay, hopefully I didn't mess up with syntax. Let's run it quickly again, just to confirm. Once we have this formula for the start date in a proper shape, we can reuse it in our, okay, so it's still, oh yeah, this is the old one. Let's wait for the new one. Okay, there you go. And now we have a proper output, and then we can pass this value to our notebooks. So now I don't need this set variable anymore. I will just deactivate it. And now I can add my notebook. The first notebook is bronze load. And here under base parameters, I can create start date and end date parameters. Provide these dynamic values that we generated by the formula in the previous example. And these parameters will be used when running the notebook when you execute the pipeline. Since again we are limited with time, I'm skipping this part. Essentially, what we are going to do, this is the bronze. This is the bronze notebook. I would add another one for silver, connect them. So whenever my bronze notebook completes successfully, then the next step is to execute a silver notebook. The final thing will be gold notebook, and optionally, if you are using this notebook to populate semantic model, for example, you can add an activity to refresh your semantic model. So this was just a brief introduction about specific tools in Microsoft Fabric that, so literally in like, I don't know, 10 minutes, we were able to pull out the data from a publicly available API, which is in semi-structured form, like JSON file, and to get to the data that is ready to be served to the end user through, for example, Power BI report. Going back to a presentation, some key takeaways from our session today. The first key takeaway is that I need to cut it down a little bit, but first thing I want to remember, for you to remember, is that Medallion is not a data modeling. Don't mix these two concepts. So this is not the same. The Medallion pattern is no more a data model approach than a parking lot is a type of car. I borrow or stole this a quote from Joe Rice, author of the Fundamentals of Data Engineering book. I like it because this best describes the difference between Medallion and data modeling. The way I like to think about this is that each stage removes complexity for an increasingly broader and less technical audience. That's the main goal of Medallion, all the things we are doing in Medallion. So removing the complexity for broader and less technical audiences. Remember, a non-technical business analyst doesn't want raw JSON. They want a clean table to query. At no point we prescribe how the data is modeled. Each stage in Medallion is model agnostic. Also, Medallion layer doesn't necessarily need to be a physical, persistent data. In our previous demo, we materialized every layer in the lakehouse, but you can and you should take advantage of some advanced features and concepts available in Microsoft Fabric, such as shortcuts, especially now with these latest enhancements, shortcuts with transformations. This shortcut is a special one lake object that points to the data stored in different location. Also, you can use good old T-SQL views to encapsulate transformation logic without materializing the query result. There are obviously some pros and cons to keep in mind, but my message here is that you don't necessarily need to physically store the data in Medallion layers. Last, but definitely not least, and I would say this is probably the main takeaway from today, there is no silver bullet medallion design. Something that works for me, something that works perfectly for company A might not be an optimal solution for you or for company B, and vice versa. So carefully evaluate your specific use case and business requirements instead of blindly jumping on the bronze, silver, gold wagon just because you heard that's the only right way to do things. To wrap up, there is no single right way to build your medallion design pattern, and it will mostly depend on your specific business requirements inside the organization where you used to build this. That's all. Really, that's all. So
Thank you
once
so
again,
much,
apologies
Nicola.
apologies for going
No. So I was just gonna mention that we already have really good discussion going on in the chat, uh, but the audience doesn't want you to stop. So if there are any additional demos, material that you want to cover, feel free to do that, because we all love learning from you.
Yeah, thanks everyone. Thanks for staying so long with me. So I would say this demo with golden layer would take quite a while, because in my tests, whenever you use a custom environment, previously when I tried this demo, it took like 4 or 5 minutes to just to spin up the cluster. So, but
Yeah.
basically that was the last thing that I wanted to show you. And
Okay.
on top of that, then you can build direct lake reports and everything else.
Perfect. Okay, so we have a couple of questions here. So first one is from Lav. So he was asking, what if in the silver layer I need to do a simple lookup from another table? So I guess his question was originating from, if we don't do any merge in the silver layer, what if I need to do a lookup from another table? Do I do that, or do you strictly keep it without any merging any data?
Yeah, that's a fair question. And again, going back, so don't be dogmatic. If in most cases, I said in most cases it doesn't make sense to merge your data inside a silver layer. If you need to do something as simple as do a lookup, then of course you can do that. Nothing of this is set in stone. Those are just some, let's say, recommendations, best practices, and then things that work for most of the scenarios that we covered today. But there will always be edge cases. There will always be some special scenarios where, of course, you can go, yeah, above and beyond what we explained today.
Yeah, and we treated that in the chat as well. There is no single bullet or silver bullet here. It all depends. Okay, second question from Jeff. How do you recommend organizing data and schemas in the silver layer? Is it by domain, source system, by audience, or anything else?
Yeah, that's that's $1 million question. Again, there is no single correct answer. It's similar question of how you organize your workspaces in domains, for example.
Yeah.
So again, depends on how this data will be used inside the organization. If you want, if it makes sense to split it by, let's say, line of business, then totally makes sense. If it needs to be geographically somehow, I don't know, Europe versus Asia versus USA, also you can do that. So it depends how the data will be used downstream. Remember, we need to make things less complex for the broader audience. That's the key. Don't forget that.
Yep. Yeah. And then I'll add to that it also depends on whether you're using any kind of data mesh architecture, whether you're creating domains, whether you are separating or creating multiple workspaces as well, and the purpose of each of those workspaces as well. Are you creating data products, and are you serving those data products by schema, by table? So it all depends. The point here is you have the tools necessary, and you should understand your end requirements and what best fits your organization and what your business goals really.
That's a great point. Absolutely agree with you. Yeah.
Yeah. Question by Vikar: by star schema in gold, do you mean data warehouse, star schema, and semantic layer? will be on top of gold layer. I think you touched on that, and I think the answer is yes.
Yes, the short answer is yes. Just to explain, you don't necessarily need to use a warehouse for star schema. You can use a lake house. So it's just the concept. Yeah.
Yep. Another question by Lav. Where does the domain-specific data mart fit here? Is it in the silver or the gold layer? So basically, where do the data marts go? Silver or gold?
Data mart should go into gold layer. That's without any discussion. Yeah. Now it depends if you want to have like these specialized data marts in an additional sub layer inside the gold. We touched upon this talking about platinum layers. So sometimes this additional layer, however you want to call it, may be used to create data marts, really specific data marts. So you take your star schema model from gold layer and then you specialize it in more detail, creating a special data mart in this additional layer. But definitely gold, not silver.
Yes. And then Jack has a question whether he was wondering whether you'll be open sourcing these Python files and notebooks, where if it will be shared or not.
Sure, I can upload them to my GitHub account. So yeah, it's publicly available data, and yeah, it's just a couple of lines of code. So yeah, absolutely.
Awesome. Thank you so much, Nicola. I really love all the engagement, the great content. You covered everything end to end, explained all the concepts. I know we ran over, but I think to really do justice to what you had prepared for, you needed that. So I really appreciate you staying longer here and then finishing everything. I know I can speak for others as well. We learned a lot, and it's great to hear from you always. So thank you very much.
Thank you,
I hope
Sandeep.
that
Thank
you
you,
will come
Parv,
back
for
again.
hosting me. Really appreciate you inviting me to present for your user group. Really
we will
appreciate
be
that.
bringing you back.
Yeah, whenever you want. Yeah, I would be happy to join again. And thanks everyone for great conversation. Thanks for great questions, and thanks for spending like almost 2 hours together.
Well,
So I hope it was worth.
You go, a couple of things, Nicola. I know you were at FabCon. What were your top 3 features announced at FabCon? What did you like? Anything in particular that caught your attention?
You caught me, but let me think. Let me think. So
okay.
Something that is available as of today, or something that is coming soon?
Anything. It could be anything.
Anything that was announced. Okay.
Yep.
Yeah. So for me personally, mirroring for SAP is big, because there are a lot of clients here in my region, here in Germany, Austria, that are still on SAP. And I think we can all agree that Microsoft and SAP integration is not the best at the moment. So I'm really looking forward to that one, because I think that will solve many problems for customers here, particularly in my region. Sorry, this is a little bit, let's say, locally focused. Other than that, I also love so this is Power BI thing, but still I think it's big, this user-defined functions in Power BI. That was also announced, but particularly about Fabric. What else? So security is still not here, so we can't talk about that.
No. Security was announced.
Public
preview,
right?
Public preview coming very soon.
That's big thing. That's a big thing. That's a big thing. That's a big thing.
Yeah,
that's
asking for it. It's finally here.
Yeah, that's a big deal. That's a big deal. So those are my 3. What about yours?
Perfect. Yeah, no, in fact, the one leg security is a big deal. I have tested it. I know MVPs have tested it, and I love where all the functionality. So look at your tenant in the next few weeks, in the next few days or so. It should light up very soon. I'm really looking forward to hearing back from the customers and the users what they think of it. And the other big one for me was Graph. I know, but they didn't show a whole lot. But
yes, Graph. I forgot Graph. Yeah.
Many use cases there. So I'm looking forward to that one as well. But
Yeah.
okay. Well,
That's
thank you
great.
again, Nicola. I'm gonna pull up my screen and then I will show my entire screen here. Let's go ahead. So we have the book giveaway. So all of you, if you can look at my screen, make sure I see your name in here. If you don't see your name, let me know because we'll pull one random attendee from here, and you will be our lucky winner for today. So I'll give you just one more minute. Just make sure you see your name. If you don't see it, unmute yourself and let me know. Okay, so let's go ahead. Drum roll, please. Number 6, Ian. Do we
Yeah.
have Ian in the attendance?
And yes, he is here. Perfect.
Awesome. Perfect. Well, thank you so much, Ian. Really appreciate it. We will be in touch with you very shortly. So perfect. Thank you so much again. Parv, do you have anything else to cover?
No, it's great. Thanks, Nicola. Thanks, everyone. Great session. Awesome. I'm pretty sure everybody learned a lot. I think we are good to go. And we will be bringing Nicola back sometime in the near future. Until then,
Happy to come.
see you,
Thanks. Thank you.
everyone. Take care.
See you,
Thank you
everyone.
again. Thank you very
Have a
much,
good one.
everyone. Bye.
Bye bye.